Welcome. Thanks for having me. It's been quite a break since my last talk. So it's like the last conference I talked was that I've given was like 3 years ago. So a little bit rusty, but looking forward to be back. Today's topic: turning it up to 11 and scaling your Rails application to about 100,000 requests per second. So this is the scale that we're actually operating one of our applications on. And basically the scale, solving this age-old thing of Ruby cannot scale, well, yes, it does. But yeah, let's get into some details on that. I'm not going to watch the chat. I'm not sure if I can see the raise hand feature because like Keynote is taking over all of my computer. But I see some faces that don't look too puzzled, so I guess it's working. If you have any questions, just interrupt me or do them afterwards. Anyway,
don't interrupt Jens. Sorry for interrupting, but please don't interrupt Jens. We'll do questions afterwards. I forgot to explain that correctly. Sorry.
Okay, then don't interrupt me. That's fine as well. Okay, so yeah, let's get started. So basically, you know that you have to think about performance the moment you see this in your Rail Academy. It's like someone just sent a advertisement on TV, there was some news reporting, or you are working for a concert platform and an artist just announced, oh, by the way, we're selling tickets and it's exclusively tomorrow at 12 a.m. Those are all the moments when suddenly you have a lot of users using your service and a lot of users just think like, oh yeah, let's click on it. And suddenly you face this challenge of, oh no, my server is just saying no. So if that happens, basically you're going like that. Uh-oh, requests are getting slow. And the next thing you see is like, oh, there's like a timeout page on Heroku. And the next thing that happens is that one of your customer calls you like, the website is down. That basically is the moment that we want to avoid. So before we get into that, the question is like, who is this guy? Or as I also like to call it, the shameless self-promotion part. My name is Jens Ravens. I'm a developer at Nerdgeschoss, and we're a dev agency for like anything that is slightly more sophisticated than your average blog. So we're helping startups and medium businesses to build whatever they think is awesome stuff. And here's the advertisement part. We can build your product too. So if you need any support, we're here. We're happy to help. Advertisement off. My name is Jens. I'm like 50% iOS, macOS. I'm a huge fan of Swift, and like the other 50%, I'm doing web and API stuff, usually in my favorite stack of Ruby and Rails and React and TypeScript. So yeah, you already heard of TypeScript. I also do a little bit of Node development, Node and Deno, depending on the application, and PHP, because everyone needs to do PHP once in a while. Also, if you're interested in all of the stuff that I'm doing, I'm blogging about Swift and also Ruby. Like the last blog post I did was on end-to-end encrypted chat applications in Ruby on Rails. Also kind of an interesting read. But also what you will find there is all the slides and all the material of today is on that blog post. Just go to jensravens.com and you get all the slides, all the material. Anyway, let's get to the topic. What I'm going to talk about today is the very first thing, but Rails doesn't scale. And I will elaborate on that. I will do a case study about one of our e-commerce customers. So a ticketing platform for ticketing, merchandise, like a marketplace. I will talk about the tools that you might need to figure out that you have a security, that you have a performance problem. And finally, I'm gonna turn it up to 11, giving you 11 tips on how to make your application faster. As you can see, 11 tips is not gonna get you to the fastest app that you ever created. It's just a starting point, and we also don't have time to get into the depth of 11 performance metrics. So it's just a broad overview of things that you might consider to actually make your application faster. But first, the question always is, okay, we go for a performance-intensive app. Why should you actually go for Rails? This is probably the question that you get asked all the time. Is like, this needs to be fast. Why do you take Rails? And usually I have two arguments for that. The very first one, speed. And this is the moment where I ask people to just like speed, Ruby, for sure. But the speed that I mean is the speed of development. Quite often if you build something, it's about getting it to the market as fast as possible. And this is where Ruby really shines. Like, you have an idea, and basically with Rails, 2 days later, you have a working prototype. It's not going to be pretty, it's not going to be complete, but it shows your idea, and that is something that no other tool set can give you. The second one is, and this is more of a long-term goal, is developer happiness. So if you go for Rails, usually your developers are just happier people, or as I usually preferred, happier people with a beard. If your developers are just happier, also they're going to be just more productive. So let's talk about the actual application performance and speed. So let's review some facts of Ruby. The first one, reg apps are blocking, which used to be the case for pretty much every framework, but nowadays most things, if you look at Swift Neo, if you look at Elixir, Node.js, all of them are usually asynchronous. They are callback based, they have some reactor event pattern, whatever. And with Rails, we are still at reg apps, which just like block, you need threads, you need processes, you need more power to scale. It's something that probably we're not going to fix anytime soon, but okay. Also, other languages might give you more requests per second for that little bit of RAM that you have. And as you all know, as Ruby developers, RAM is like the most precious thing we have. And now I'm going to tell you a little secret that I can give you as being the CTO of a tech company. Like, those are really valid points, but I really don't care about it. There's one very easy answer to debunk the whole performance per language myth, and that is this look into my spendings as a CTO in a tech company. So as you see here, those are the biggest cost factors of my company. And as you see here, like 89% are salaries. About 8% is for the office, and about 3% actually goes into server cost, management contracts, like everything to keep the hardware running. Which means if you look at those spending, that means faster development equals more revenue. And that's something we like as business people, but also like as developers. So as a developer, if you can pump out your features faster, we get so much money that actually we don't care about the hosting part anymore. So to summarize the whole thing, Rails is actually fast enough. It doesn't need, like, sure, a little bit faster is always nice, but it's not the main focus, keeping it as fast as possible. We should actually focus on keeping our developers performing, because that's where you can actually get the biggest revenue as a company, but also have like the nicest impact, because usually someone who's productive at their job, they're also quite happy about their job. So let's get a little bit more serious about the performance though. The case study that I'm doing today is about one of our customers called Kassastoff.com. They are a ticketing agency, so they do ticketing and merchandise for mostly European artists in mostly the European market, but actually they have a worldwide distribution network. What you can do on their website is basically buy tickets for events. We have like all those things that you accept from a big event page. We have arenas, we have seat map booking, we have pricing categories, we have like everything that you can name off in terms of events. And the thing is running everything from the actual event booking to personalized home pages for artists. So it's a multi-shop system that in the end serves around, I think, 300 different web shops, all running on the same API. And of course, there is the whole admin part of it as well. Security indication, all of this is fake data. Don't even try to copy those codes. They're not going to work. So yeah, basically the whole admin framework, this serves everything from creating a ticket to planning a venue, to drawing a seat map, to writing invoices, to bill artists afterwards for the services we are doing for them. Short, it's huge. It's around 90 models, currently around 90,000 lines of code. It's a lot of work to maintain it. The reason why I'm taking this as an example is because for short amounts of time, we have immense traffic on this. So talking about numbers is like usually it's really idling. Like it's idling at about like 10% capacity of a single Heroku dyno. That's like 90% of the day. And then comes the moment where one of the artists that we feature on this website do an Instagram post. And if they're nice, they tell us upfront about it, but most of the time they're not, and they just schedule their stuff. And suddenly you have like 100,000 people trying to buy a ticket. And of course you have seat net booking, and you have like a limited amount of tickets. You don't want to sell a seat twice, so there's a lot of validation, so there's a lot of database work, and suddenly your database is burning. So today I'm going to take you through the whole travel of how we made this thing fast, or at least faster, and what are our next steps in, well, getting even more performance out of it. So the very first thing about this is whenever you talk about performance, you have to measure, then you implement. So after measuring first what's wrong, and then you repeat the cycle all over. So performance is not, again, like security, not a checklist on your pull request. Performance is something that you constantly evaluate, that you constantly improve. So it's kind of parallel to the development process. The very most important takeaway from this slide is don't implement something before you measured it before. If you don't measure, you don't know if it improved. You don't know if maybe you actually made it worse, and you cannot compare it to later. That also means after you measure, keep a record of all of it. That can be an Excel sheet, that can be a piece of paper on your desktop, like whatever it is, but measure your performance. And I come to what you can measure a little bit later, and keep those records so we can always compare, okay, we did a change, it got faster, it got slower, and then you can nail down what actually went wrong. But never implement anything without measuring first. Because quite often your intuition is sending you in the wrong direction. Some tools that can help you in the process. So let's talk about some companies. So the first one, if you are hosting on Heroku, and we're actually hosting that thing on Heroku, they give really good metrics. If you need more metrics, and if you, for example, do memory optimization, which is a big part, there are extensions on in the Heroku beta program that give you really deep insight into heap allocations, into memory slots. So if you're debugging that stuff, actually Heroku has the best data. You don't even need an add-on. One minor drawback of the Heroku dashboard, though, is it's about 3 to 4 minutes behind the actual server load. So whatever you see in data is about 4 minutes old. If you have constant load, that isn't a problem. If you are in one of those load situations which we have, where load goes up by like 10,000% in less than 30 seconds, you might be down, and probably you don't even see it yet. So whenever you look at those logging tools, they take a moment to come up to date. Which brings us to New Relic. New Relic in the free edition is quite often enough to measure things. It gives you a breakdown on what part of your stack needs how much time, what your average response time is, and basically what I usually call the mint graph of death, the request queuing. So if your server gets more requests than you can handle, you have this mint green thing going up and basically telling you of impending doom. If you see mint green, usually it's too late. Because again, it's a logging tool and it's about 3 to 4 minutes behind the actual data. So again, here, if you see mint green, that means you actually went offline about 4 minutes ago, which, if you're time sensitive, is a big deal. Another one, Sentry. I love Sentry error reporting. Just gives you really deep insights into everything that goes wrong, especially if you get 503 errors for performance timeouts. So if you're running into timeouts because you don't handle enough requests, actually those stack traces give you a lot of insight on what actually went wrong. And because those things usually only happen in production, that's where you can look. And last but not least, Skylight. So all the other tools that I mentioned before, they always have this 3 to 4 minutes delay, which for us is always too slow. And that's why I love Skylight, because Skylight is about 20 seconds behind the actual data. So if we go offline, I see them Skylight about 20 seconds later. They're a lot faster than the others. And that's the main reason why I use Skylight. It's just quicker response time from, I changed server configuration, did it fix it? Yes, no, Skylight gives me the answer. Again, everything linked in the slides, so just download and click into that. But yeah, let's talk about the actual, like, we measured it, we know something is slow, how can we actually fix it? And I'm gonna go over some ideas. So yeah, basically, performance tuning means you're changing your tires at about like 65 miles an hour on the highway without even stopping. And then you decide, oh yeah, let's also change the engine, but still I don't want to stop. So performance is always something that runs in parallel, and you just don't want to stop feature development to just like build a new performant application. Little side note, rebuilding the application will not make it slower. Once you implemented all the features again, it will be just as slow as before. So just stay away from the rewrites. So let's talk about 11 points how you can make your application faster. Those are just anecdotal things that we've done and that helped us. It's not a complete introduction to performance. I'm trying to stay away from the obvious things and just go for things that were a little bit more surprising to us. Also, it's not going that much into that. It's really just giving you some options on where you might look. So let's start with the first one. Actually, just scale that thing. Quite often, you're just dealing with short moments of performance spikes. As I told you before, usually your job is quite an expensive position on the payroll of the company. So if you can kill a problem with money, usually that is something that companies like. You just throw a little bit of money on it and this problem goes away. Actually, that's fine most of the time. So don't spend like a full month on optimizing something that saves you $5 in the end because it's going to be more expensive for the company. In terms of performance, if scaling to more dynos makes your application faster, maybe it's just enough. So the trick here is really just think business-wise, not developer-wise, because as a developer, we of course want to deliver the best possible application. But it's quite often the business looks a little bit different. Also, if you only need to scale for like that half hour between the TV spot is running and your application gets a lot of load, it is okay to scale up to 100 times. Just make sure you don't overload your database. The next one, still quite obvious. If you have problems at the database, just do a follower database. If you're on Heroku, it's literally as easy as clicking on create follower. And we are on Rails 6, so doing main databases, replica databases is not that hard. So it's basically a few lines of configuration, the cookie management. So if you don't do a lot of caching, actually it's as easy as like a few configuration files and you run in the main follower database environment. The next one, and actually the most effective thing that you can do is HTTP caching. Probably you already have running something in front of your application, like your Puma nodes are not directly exposed to the internet. Maybe you have Cloudflare, you have Fastly, you have whatever your own Nginx configuration, but probably there is something in front of it that can actually cache stuff. So if you do HTTP caching, this can take a lot of load off your server. So example here, this is from the CPAN controller, so chunking out JSON from our database that renders the SVG on the web page that actually renders seats. This is one of the heaviest parts of our application because a seat map is big. If you think about something like the Olympic Stadium in Berlin that has 79,000 seats, all of them having X, Y coordinates and a name. So that is quite a lot of data sent over the wire. You can compress it, but still it needs to be rendered, and that takes a while. Just putting that one line in there, expires in 1 hour, public true, and having any kind of caching in front of it, make sure that you only get 1 request per hour instead of 70,000 requests per second. This is one of the biggest things that you can have. It doesn't only apply for API applications, so Kasserstoff is mostly API and an Angular application in front of it, part Angular, part React. This actually applies for all kinds of workloads. So if you're going for API with REST, if you're going for GraphQL, GraphQL is a little bit more work because in GraphQL everything is post request. But if you look at Apollo extensions, you can actually turn Apollo post requests into GET requests and cache them as well. We are doing that, for example, for bundles. So if you can buy any kind of product bundles, that is quite an expensive calculation. So just finding out if something is in a bundle needs joins across 8 database tables. It's just really expensive thing. We cache that with GraphQL in a GET request, and it works really, really well. Because also bundles don't change that often. So if they're 10 minutes behind, totally fine. So yeah, HTTP caching also works on HTML sites. So if you have like a home page, just load all the user relevant data with JavaScript afterwards. Works. Toollinks also is going to give you a lot of help. Like you render the static standard page for everyone, just an HTML. You load the remaining stuff as JavaScript, put toollinks on top, make them persistent elements, and suddenly you have a personalized website that is still HTTP cacheable. So this is probably the first thing you should look into. It's a little bit of work, but will give the biggest benefits that you can have. Next layer of caching, the application cache. So if there's stuff that you need in different places and you need to invalidate it yourself, the Rails cache is your friend. It's set up by default, usually as a memory cache. You can put any kind of things behind it, but it really makes your application screaming fast. There's a drawback though in caching. Sometimes the application cache can make your application slower instead of faster. This is actually one of those examples where we had it, and this is where we built the cache inside very deep in one of our models. So to find out the net price of something, to not make the database request, we just went to the cache instead. But now instead of preloading things, we were doing, when we rendered like 20 events, we needed to do 20 queries to the cache. So with a cache, you can also have an n+1 query. So be careful with your caching. It can make your website slower. If you do that, there's multi-fetching caches, but that is basically the moment where you get like really dirty in your model. So it can help you, but again, measure before, measure afterwards. Cache can make your application slower. You have to look at the numbers. The next thing, hunting down n+1 queries. Probably you've seen something like that in your logs before. n+1 queries is this, like, you render a list of things, and everything needs to load a list of other things. Usually the easiest way to see them is just to look in the logs. Usually your logs should be short enough to fit on like 1 or 2 screens per request, and then you like easily see if there's an n+1 request. That's usually the easiest thing. There's also gems that help really. Like if there's a Boink, like one of the best named gems ever, because it oinks whenever there's an n+1 query. And this is one of the things that will just tell you like, oh yeah, there's an n+1 query, you probably should do an include. The problem though about those n+1 queries is if you just include everything, you probably include more than you needed in the first place. So again, this is one of the performance optimizations that can make it slower instead of faster. So we have this case where we have prices for events that change over time. Like from next Tuesday until Thursday, there's going to be a discount thing where events are half the price for certain events. That means we have to load several prices to find out which one is currently active. And also we offer that in multiple different shops, and depending on the shop, there might be a different price. So there's a lot of things to include. And if you include a lot more objects than you actually need, again, you're using a lot more memory. More memory means more garbage collection, means it's slower, more CPU. So yeah, again, first measure, then implement, then compare your numbers. One particularly nice snippet that I like for finding those queries is this thing here that I have in the initializer in production. So if I really want to profile how is my real world application doing, I basically subscribe to all the active record notifications and I just pipe them out to the standard log. Like whatever platform you have, usually there's a way to just attach yourself to the standard logging, to standard out. And I write that down as a CSV file. Why CSV? Because if it's CSV, you can use an application named TED, which loads your CSV into an SQL database, SQLite, and you can do all kinds of aggregations. So you can filter by product, by payload, look for certain durations. And I can just filter down like, okay, which endpoint is doing how many SQL requests, how many of them are writing, how many of them are reading. And that way I can identify which of my endpoints need the most attention. This is also nice because it attaches to a live stream. So we are not at this, we are 5 minutes behind load, but I can actually see the live load of my application. And it's really lightweight, it's just logging stuff. The next one, being conservative about your tech choices. I know we're developers, we like new, shiny, fancy stuff, but quite often old things are just enough. So this is a blog post that really struck me last year when it came out, where someone analyzed the traffic of a Google page and basically wrote in a pretty long blog post why it's wrong what Google is doing. While I'm never a big fan of telling someone like, oh, it's wrong what you're doing, like I think that's like a general problem. The one thing to always keep in mind is probably there was a tech choice behind it. So let's think about polling versus pushing. If you need any kind of real-time data, probably your first reflex is like, oh yeah, let's just throw a WebSocket on it. We have action cable is nice, action cable is relatively fast, and then you realize it doesn't scale at all. And then you try to fix it with any cable, and you run that extra Go server, and you have like pretty complicated tech requirements that you have to maintain that are hard to test, that are basically just a pain in the ass. So think about, is it really necessary to be real time? Maybe it's okay to be like near real time and just poll every 30 seconds. If you combine polling with an edge content delivery network, like you put Cloudflare, you use HTTP caching, and then you poll against the thing, it's almost no load for your server. You don't have to maintain all the tech stack, and probably it's still real-timey enough. So it's just about showing a notification to someone. 30 seconds later is probably still fast enough. So really think about your tech requirements and if you really need all that fancy stuff. The next one, small responses and batch loading. The smaller your response is, the easier it is to cache. If you include less stuff, you need to cache less, and you need to invalidate less. Also, if you're on the API side, so if you're in GraphQL or in just rendering a JSON API with, for example, active model serializers, there's something called batch loading. So in batch loading, it's a different way of preventing N+1 queries. So instead of including things up front, you load them asynchronously when you need them. The nice thing about batch loading is that you don't need to think about nested includes. So our crisis problem that we had before, where we had to include tons of things because you can only include a full relationship and not just a few of them. In batch loading, you don't have the problem because you only need to load what you need the moment when you need it. And it's really easy to implement. So if you haven't heard of batch loading yet, there's also a blog post that I linked here that explains how to do that for REST APIs with active model serializer. GraphQL is basically impossible to do without. So it's something that you definitely should add to your arsenal. Also, SQL is your friend. I know we all love active record, but still SQL is there at our disposal. And this is one of the examples where we, again, have to do a CSV export, and loading active record things is slow. So why not actually rendering the CSV in your database? So if you have read replicas, you basically have unlimited computing powers in your database. So you can just generate the actual file in SQL. And because most databases, so talking about Postgres or MySQL, you can actually stream your results directly to the client. So if you take the stream from your database, you put the stream on your client, you can do like unlimited size of CSV or JSON or whatever your database can produce and directly pipe it to the client. Nothing is going to beat that in speed. We, for example, do that for seat maps of events, so like those rendering 79,000 seats. No dyno of Heroku could fit 79,000 active record instances into memory. While doing that in JSON takes about 40 milliseconds. Also embracing eventual consistency. So think about things that can change in your application and you don't have to do everything right now. If you have performance problems, just queue all your stuff for later. Active Drop can do that for you. This is a screenshot from one of the internal libraries we're using. So basically an event bus where you can dispatch events from one part of the system to another part and then act on them. And here we're using priorities. So we say like, okay, if we get a Stripe payment, it's not so important to process it right now. If you process it in 5 minutes, it's still fast enough. We don't need to confirm it right away. Or if we want to clear an invoice, so bill it to the artist, we don't do it now, we do it in 30 minutes. Still fast enough. If the artist gets the invoice a day later, no one cares. Next one, avoiding locks and mutexes. So one of the archetypal things that you find is counters in databases. So think about you are selling your next event and you only have 20 tickets. How do you track how many tickets you have sold? Well, either you do a lot of count queries or whatever, but quite often a lot of developers just resort to, they have a counter somewhere in a table, like in the event, how many tickets were sold, and they increment it. Hopefully you use increment, so you don't run into race conditions. But yes, still you have the problem that when you update it, you lock the table, nothing else can happen. If you have 100,000 people at the same time buying a ticket, that's not going to cut it. This is where like all of the queries will wait for each other and you just start blocking things. And this is something you will only see on the load and never while you test. So one of the examples where you can do that is instead of counting things, just create those things in table and give them a status. So for us, that is for a single ticket, there is this available flag on it. And then we use a little trick that is possible in Postgres. So with a common table expression, you can actually lock a row and skip over that row, and at the same time update it with an amount. So for example, here we say, okay, give me 3 tickets. So we do a common table expression to select 3 random tickets, just lock them, and only those, and set them to available. If anything else happens at the same time, they will skip those locked tables, and in the end, we return the IDs. And this is basically the trick. So we just randomly allocate 3 tickets, and we return the IDs, and later on can tell, like, these are the 3 tickets that you allocated, without blocking anything. So nothing in this will block any of your table, and you can allocate things in a very performance efficient way. And the last one, if really everything else breaks, just hold the door. It's still better to give a nice experience to 10,000 visitors than give a shitty experience for 100,000 users. So one of those things is we have a waiting queue in our system. So if really hell breaks loose and we cannot do anything anymore, every single Rails session has a consecutive number and is in Redis. And in Redis, everything is scored by when did they get into the shop. So if someone is doing a request, so for example, for doing something with a card, so any writing operations usually, we check, okay, currently we can only handle 50,000 users because something went weird, PayPal is not working or whatever. We just make sure that the first 50,000 users in our system still can use the website, and we just show to the rest, like, currently there is something happening, but as we know the queue and their position, we can even give them an estimate, like something is happening, but in about 2 minutes you can go shopping. Also make sure that you have some stats about it. So we have a built-in dashboard in our application that tells us how many people are browsing where, how many people are currently waiting, and if there's waiting time, for how long is the average user waiting. So do we need to do any social media responses, like people are starting to shit about us on Twitter? Probably we should respond to them, and usually that happens about like the first people have to wait more than 5 minutes. So those are my 11 things, and as we know about performance, there's always, well, the n+1. There's one extra thing, and that is keep it simple. So performance quite often makes your application code a little bit more complicated, because you have to preload, you have to include, you have to batch load. All of those things usually add complexity. So only do that if you actually need it. This also is about architecture. A lot of architecture choices might make your application slower. So again, measure and repeat. Keep your application as simple as possible. So the application that I just showed you, we're maintaining that for several years. I'm still really happy because we can still find whatever we need in the places where they should be. And I just did the stats yesterday. So we have currently 79 controllers, 84 models, 79,000 lines of code, and it's still basic MVC. So we have model objects, we don't have presenters, we don't have interactors, or we don't have form objects, because actually the stuff that we do, we try to split it up. We use just object orientation and MVC, and it's still simple. And because it's simple, we can performance optimize it. We don't have to work around an architecture. We are just going with like the standard architecture that every one of us knows since like 84 since Smalltalk. So yeah, that's basically it. Thanks for watching. All the slides are on my website. All the tips are there. If you have any questions, just like ask me today, or if you're watching the recording, just hit me up on Twitter, and I'm happy to give any kind of advice. Thanks.